Today's daily LeetCode problem of the day is delete nodes and return forest number 1110. For this problem, we're given the root of a binary tree, and each node in the tree has a distinct value. After deleting all the nodes with the value in to delete, we are left with the forest or disjoint union of trees. We want to return the roots of the trees in the remaining forests, and we may return them in any order. So in this example here, our original tree is 1, 2, 3, 4, 5, 6, 7. We want to delete 3 and 5. So if we delete 3, it leaves us with 6 and 7 alone. If we delete 5, it doesn't really change anything, but 2 no longer has its right kid. So our goal is to return a tree node, so we only have to return the root. So in this case, we'd only have to return 1, 6, and 7. This is just showing us the example tree that can be made from it. So for this problem, we are first going to initialize. We're going to initialize our list, which is what we're going to return. So we're going to have a list of tree node. We call it our forests. This is going to be equal to a new array list. We're going to fill it as we go along. So here we'll do list to store all root nodes. Then we're going to have a hash set to store to delete for easy lookup. And then to identify all the nodes that we want to remove and create our list, we are going to use a post order traversal to find nodes to delete. And we're using post order because this allows us to allows us to look at children, pause, before killing the parent. And then we simply have to add root if not null and return our list. Pretty simple. So let's add our values to our hash set. So we're going to have a set of integer. We could call it delete. It's equal to a new hash set for int I into delete. We're going to do delete dot add I. So now we added all of our integers into delete into our set for an easy lookup. Now we want to do our post order traversal. So we're going to equal our root to our order. And in our post order, we're going to pass it a couple things. We're going to first pass our root as our main node that we're going to start with. We're going to pass it our forests, because that's the list that we're going to be updating. And we're going to pass it delete, because that is what we're going to be wanting to delete from our tree. So let's build this function. So private, we're going to return a type tree node, post order. So our first argument is a tree node. We could call it temp. Then we're going to have a list type tree node. We could call it list. And then a set type integer. We could call it delete. So first things first, this is going to be recursive. So we want to check if the node that we're on is null. So if temp is equal to null, we can return null. Otherwise, since it's a post order traversal, we're first going to look at the left node. So we're going to look at temp.left, look at temp.right, and then we'll address temp itself. So temp.left will be equal to whatever the result is of post order as we pass temp.left, list, and delete. So if post order returns this as null, we'll use that in the future. Then temp.right will be equal to post order of temp.right, list, delete. So now we have already done whatever the rest of this function is going to do for the left node, for the right node. So what exactly is it that we're going to do in this function? First things first is we're going to identify if the node is in our delete set. So if delete.contains temp.val, that means this value is getting deleted. So we need to address the children nodes first. So the current node that we're looking at is getting deleted. What are we going to do with the kids? We're going to add those kids to our list because they're now their own individual forests. That's why we address the left and the right first, so we could check if they're null. So if temp.left is not equal to null, we can do list.add temp.left. Then we could do if temp.right is not equal to null, list.add temp.right. So that's why we addressed our children nodes first, is so we can simply identify if they already returned null. If they didn't already return null, we can add them to our list and go about our day. Then we're going to, because we just deleted this node, we can return null as the temp node that we are currently on is null. Otherwise, we can return temp as we did not make any changes to it. So let's say temp.left is not in our delete set and it doesn't have any children. So we pass temp.left. Is it null? No. We look at its left. There's no, it's going to return null. We look at its right. It returns null. Is temp.left in the contains? No. Or in the delete? No. So then we just simply return it. It shows up back here. We look at it here and we add it to our list if we delete its parent node. So that is it for our post order traversal. Now we just want to identify if our root node is null. Root is not equal to null. We could do forests.add root. Then simply return forests. If we run this, passes our test cases, and if we submit it, passes all solutions. So let's do this in Python. So our solution in Python should be the exact same. So first thing we want to do is identify make our list, make our set, post order traversal, add root if not null, and then return list. So let's make our list. We'll call it forests again, and that's equal to an empty list. Let's make our set. We'll call it delete again, and it's equal to an empty set. However, let's fill our set real quick. So for I in delete dot add I, and that should fill our set. Now we're going to equal our root to self dot, we could call it post order again. We're going to pass our post order our root. We're going to pass it our forests, and we're going to pass it our delete. Then let's just finish this main function off since we already know what we're doing. If root not equal to none, we'll do forests dot append root. Then we can simply return. Now let's define this post order function. So define post order. It's going to return, it's going to have self, it's going to have temp, it's going to have list, it's going to have delete, and it's going to return type tree node. All right, simple enough. If temp is equal to none, return none. Otherwise, we're going to do temp.left is equal to self.postOrder, temp.left, list, delete. Should I not be using list in Python? Probably not. Let's use forests. Jeez. And delete. Then we can do temp.right is equal to self.postOrder, temp.right, forests, delete. Then we're going to address the current node that we're on. So if delete dot contains temp, if temp dot left is not equal to none, list forests dot append temp dot left. If temp dot right is not equal to none, forests dot append temp dot right. And then we can set temp is equal to none. We just return none. Return none. And then otherwise we return temp. So if we run this, so actually for Python, we don't even need to make a set, I'm pretty sure. So if we get rid of this, instead we pass our to delete, we could just do delete dot, or if temp dot val in delete, that should work too. Yep, so that passes our test cases and passes all solutions. So thank you, and follow for more daily LeetCode solutions.